Hello sir and to all of you, this is Akash Patel and today we are going to demonstrate a week 6 experiment. So without further delay, let's get started. So this is the experiment number 6. In this experiment, we will be able to learn LTspice software as well as the voltage regulator with the help of the Zener diode. So first we will construct this circuit, voltage regulator circuit at this LTspice software and try to find out desired output, and then we will replicate same thing in the real life experiment. Okay, so let's get started. First we will construct this circuit diagram as shown in this figure. So yeah, we have constructed this circuit as we have shown that circuit diagram. The question says that the voltage should be a triangular form with the peak voltage of 0.5. So for provide this type of the input voltage, first right click on this voltage symbol and choose advanced setting, and here we choose pulse and just fill these boxes. We want initial voltage 4.8, on voltage we want 3.8. we didn't want any delay in the graph, input graph, and the rise voltage we want, which is peak voltage 0.5, and fall voltage should be 0.5 also. The on voltage should be 0 and the period I will prefer 0.5 something. So hit OK and yep, our voltage is completed. Now it's time to provide R1 value. So as per question, R1 should be 250 ohm resistor, and R2 will be regulate, but I will prefer first fix 1000 ohm something. As per question, we will have to use the Zener diode 3.6 reverse biasing Zener diode, but when I saw the library of this software, I didn't be able to get any type of the 3.6 voltage reverse biasing Zener diode, but I will create myself the 3.6 reverse biasing Zener diode. So first I have provided my Zener diode name, my Zener, which is my Zener, and let's provide the value of this forward and reverse biasing. So hit enter. One more thing we have required, we want that graph which be in the range of the second. So I will prefer 10 second is more for the graph view. So for it I will follow same thing, right click on anywhere and go to draft, then spice directive, and here we will write dot trend 10, which is tell about that the graphs should be in between the 10 second. Hit enter and yeah, everything has been completed. So it's time to just take the output graph. So let's simulate this and look at the desired output. First let's see the output voltage, how it look like. So for it we will just touch the R1, and yeah, you can see the graph is, so this green one graph is the output, and let's see the input voltage also, and yeah, you can see this is the blue one graph is the input voltage. So our goal is simple, that we will regulate R1 and try to find out this output green one graph lie between 3.6 to 3.4 in between. So this is the our experiment. So for it I will just increase R1 for the desired output. So let's do it. As you can see, when R1 is 800 ohm something, then the peak of the output voltage is just clipping started, isn't it? And when R1 is 1K, then we can see that the upper part of the output voltage is 3.6 something, but the lower part of this graph, it is not on the 3.4. So let's further more increase the R1 value. So yeah, as you can see, when R1 is a 2100 ohm resistor, then the lower part is on the 3.4 voltage and the upper part also 3.6 voltage. So this is the graph as we have expected, and yeah, we have successfully find the range of this R1 voltage, which is the 2100 resistor to the 10k resistor. So let's look at the both graphs, input and output, and how it look like. Let's see. So as you can see, the output graph and input graph, it's look like pretty. Yeah, so let's move further. Now let's increase R2 value. I will just prefer 500 ohm resistor, and this time we will use R2 as a 500 ohm resistor and regulate the R1 and find out the desired output voltage, as we have expected 3.6 to 3.4 it should be. So let's get started. So as you can see that if R1 is a 4200 ohm resistor, then the output graph same as we have expected, in between the 3.6 to 3.4 something. Yeah, so the range of the R1 is 4200 ohm resistor to the 10k resistor something. In the third part, we will have to add the same Zener diode in the series of this given diode and find out same thing as we have found previously. So as you can see that if R1 is a 1200 ohm resistor something, so I'm unable to get exact the output 3.6 to 3.4, but yeah, we can say that it's a round off the value. So if R1 is 1200 ohm something, then we are able to get desired output, as we can say that in this case. So yeah, the first part has been completed overall, and let's move further the second part. So I'm going to create this circuit as provided. So I'm just using in series of this input voltage 250 ohm resistor, and the parallel of the Zener diode I don't have the 20k resistor, so I will use this 15k resistor something. So this yellow one wire for the channel A, and this gray one wire is for ground, and the white one wire for the channel B. So first I have just choose the triangular wave and provide the range of this peak to peak voltage 4.8 to 4.3 something, and let's look at the output voltage. It should be 3.6 with 3.6 to the 3.4 something, I mean in between. Yeah, you can see this. The output is something like between the 3.6 to 3.4 something like that. So we can say that we have just find same thing as we have expected. So yeah, we have successfully demonstrate experiment number 6 with the help of this LTspice software, as well as same replica with the experiment form also. So thanks.